Welcome to Ask and Learn.
To calculate the tension in each cable and the reaction at A, we need to draw the free body diagram for the beam to identify the forces. Now, here we have six unknowns: TFG, TDH, TBG, RAX, RAY, and RAZ. The coordinates of the points are A is equal to 0, 0, 32. B is equal to 12, 0, 32. C is equal to 12, 0, 24. D is equal to 12, 0, 16. E is equal to 12, 0, 8. F is equal to 12, 0, 0. G is equal to 0, 0, 41. H is equal to 0, 16, 16. And J is equal to 0, 16, 0. Now apply the equilibrium equation. First, we need to locate each point with respect to A. So we can write RBA is equal to 12I plus 0J plus 0K inch. RDA is equal to 12I plus 0J minus 16K inch. REA is equal to 12I plus 0J minus 24K inch, and RFA is equal to 12I plus 0J minus 32K inch. Also we need to find the vectors. So the vector Fj is equal to minus 12I plus 16J, and the magnitude of Fj will be the square root of 12 square plus 16 square gives the answer 20 inch. The vector dH is equal to minus 12I plus 16J, and the magnitude of dH is equal to 20 inch. The vector BG is equal to minus 12I plus 9K, and the magnitude of BG is equal to 15 inch. Now we can find the tension as T Fj is equal to Tfj into Fj vector upon magnitude of Fj gives the answer Tfj minus 0.6 I plus 0.8 J. Similarly, we can find TDH is equal to TDH into minus 0.6 I plus zero point 0.8 J, and TBG is equal to TBG into minus 0.8 I plus zero point 0.6 K. Now, as we know, the sigma m is equal to 0, that means m is equal to r cross f this is the K. Okay, moving further, sigma ma is equal to sigma r cross f is equal to 0. So let's take the cross product of r and f gives us the equation 9.6 TFJK plus 19.29 into 6 TFJ J so, plus 25.6 TFJI plus 9.6 TDHJ plus 12.8 TDHI minus 7.2 TBGJ minus 288K minus 576I is equal to 0. Now, in this equation, we know that sigma m is equal to 0, so we can equate the coefficients of ij and k to 0. So first of all, we will do it for the I coefficient. So let's find the coefficient of I are 25.6 TFJ. This is the I coefficient. Another I coefficient is 12.8 TDHI. This is the another. And the last one is 576I. So we are taking the sum of this I coefficient and equating to 0, which leads the equation 25.6 TFJ plus 12.8 TDH minus 576 is equal to 0. Let's say equation number 1. By equating the J coefficient, we will get 19.2 TFJ plus 9.6 TDH minus 7.2 TBG is equal to 0. Let's say equation number 2. And by equating the coefficient of K, we will get 9.6 TFJ plus 9.6 TDH minus 288 is equal to 0. Let's say equation number 3. Solving equation 1 and 3, we will get this one and this one. We will get TFG is equal to 15 pound and TDH is equal to 15 pound, and from equation 2 we can also get TBG is equal to 60 pound. Now, as we know, the sum of forces in the x direction is equivalent to 0. So by summing all the forces in the x direction, we will get RAX is equal to 66 pound. The same way, let's take the sum of the forces in the y direction. We will get phi is equal to 0, then we will get RAY is equal to 0 pound. And summing the forces in the z direction, we will get RAZ will be equivalent to minus 36 pound. And to write the full equation of RA, as we know, RA is equal to RAXI. That means in our case 66I plus RAYJ, which is 0, and plus REZK, which is minus 36K.